Hi everyone, welcome to this OpenShift Commons briefing session. My name is Rosa Guntrip and I am part of Red Hat's marketing team. I am within the Cloud Platforms business unit and I look after both OpenShift and OpenStack from an edge computing perspective. Today we have Wolfram Richter, who will be presenting a really cool session around the linkage between edge computing and industrial manufacturing. With that, Wolfram, I will let you take it away.
Great, thank you. And by the way, congratulations for really having a great German pronunciation of this rather complicated name.
6 years of German.
So today's topic is edge computing and industrial manufacturing. I have some echo here. Yeah, perfect. So today's topic is I want to really discuss what is actually the manufacturing industry and what does edge computing mean for the manufacturing industry. And then I wanted to spend roughly half of the time that we have on a demonstrator that we built that shows how we can build, deploy, manage software and artificial intelligence applications in a factory edge environment. And then we hopefully have a couple of minutes for Q&A in the end. So let's dive right in. What is this manufacturing industry? It's really a umbrella term that we use at Red Hat to cover different industry segments. So we're talking about anything that is actually somehow produced in a plant. So that could be high value assets like cars. That's basically our lighthouse vertical where we do a lot of work in the automotive space, but also, for example, shipbuilding, trains, aerospace, and defense, for example. But it could also be consumer goods or industry parts like electronics or home appliances or power tools. And what's also included is chemical companies, rubber, pharmaceuticals, so anything that is not manufactured in a discrete fashion, but more as a industry process. And all of them, they have in common that they have a form of plant that is to be managed that actually produces stuff. The way that those manufacturing companies are structured, and we took the automotive example and extended it really to other industries as well, is that they have a value chain which sort of is in 4 different steps. You have an R&D development where you get from an idea to an offer. Then you usually have a sales and marketing area where you go from an offer to an order. Production logistics, the order to the actual delivery, and once it's delivered, you have an after sales or services division that looks after delivery to customer care. And that might change a little bit depending on the industry. So if you're not doing build to order or build to stock, you might actually produce before you sell, but these are minor details. And that is supported by classical IT functions as well as the corporate strategy. And the interesting thing is that basically in all of these value chain areas, there are opportunities for edge, right? In R&D, for example, automotive manufacturers, they are now doing huge works around autonomous driving. And of course, each one of these research vehicles is an edge computer which gathers petabytes of data and needs to be managed, ingested, and stored somehow into a central environment. In sales and marketing, very often you have flagship stores and retail outlets that need to be somehow managed. So there you also have edge. And after sales and service, right, a connected product like a connected car or even a connected home appliance is some form of edge device. But today we're really focusing on this production logistics piece where we're looking at what actually happens in the factory space. We've shown this slide or a slide similar to that in yesterday's presentation by Nick, where he talked really about Red Hat's overall vision for edge and how that will reflect in our product landscape. Broken this down towards factory edge, we're really talking about the end user premises and device edge areas. So the far edge right before the actual sensor and the device, where we sort of want to be in the factory and want to do integration scenarios like manufacturing execution systems integration, predictive maintenance, quality assurance, augmented reality, or even controlling autonomous transport systems. And that is usually not that easy because you have different stakeholders. There we suddenly talk about OT, operational technology, versus IT, information technology. You also have special technology requirements. And very often we see that due to very long depreciation cycles of the production tools that are deployed out in the field, it's not that easy to have them, or it's not that easy to always keep them very updated because you don't want to change a running system. So what they usually do in the factory is they surround everything with firewalls, and it's very hard to actually connect to something that is out there controlling a production process. So diving into it a little deeper, what are we talking about? So we're usually what we see in our customers, especially in global manufacturing customers, which have a number of plants, is that they have some form of hierarchy. They have, of course, a headquarter or potentially multiple headquarters and headquarter data centers. Then usually in each one of the major geographies there, and they have regional data center where they can aggregate and control on a regional level. But then also each plant has its own data center, and I put data center a bit in quotation marks because you shouldn't expect like a cloud level data center there. It could just be a rack in a room, and don't expect 3 fire zones. Be glad if you have 2 separate rooms and stuff like that. But each plant usually has its own IT control center that allows each plant to run independently. Because one of the things that is paramount in manufacturing is that the level of investment in a plant is so high that we cannot really tolerate a plant being down. And we don't want a plant being down just because a connection to the regional data center got severed or something like that. So each plant needs to be able to operate autonomously. And we do that through, or manufacturers do that by basically having all the control functions within the plant, all the logistics and the actual production control to be localized in the plant. The plant data center usually doesn't do the actual production control. Each production line usually has some form of line server that is a ruggedized PC where certain connections take place, where you can also do process monitoring, etc. And the actual production control is done by specific devices, programmable logic controller that that are basically fail-safe, are safety critical, and they actually do the control of the production process. Going from right to left, we have an increasing scale and increasing order of magnitude the amount of devices. And it's very common for large manufacturers to have, for example, hundreds of plants with thousands of line servers and then 10 or 100,000 of devices that actually sense or control things. And somewhere between the line data server and the plant data center, there is this convergence between operational technology and information technology, and those things somehow work together. Industrial manufacturing is a bit different from telco edge in different trade-offs that you have to make, right? If, for example, a 5G cell within a telco network dies, very often it's basically only affecting a small subset of the customer set, and also other cells can potentially take over by increasing their radio output, etc. Whereas in manufacturing edge, right, the production must never go down. So you have different requirements with regards to uptime. For example, it can usually operate in a disconnected fashion much better than telco environment, where being disconnected means, well, calls get lost. You have very long living investments there, so we have to always think about brownfield environments where we have invested in certain machinery that is out there and that just needs to be connected. And I mentioned before, right, everything is separated behind firewalls, and it's usually a policy that you cannot connect, for example, to a line server from the regional data center, just because basically the line server is something that needs to be protected, so it's hidden behind firewalls. So the discussions we usually have with customers around, well, I'm now using modern technologies in our corporate data centers, and we really love these cloud environments where we have APIs for everything and we can easily deploy new applications and new software. And they ask us, well, how can we do the same thing also now towards our manufacturing plants? How can we achieve real-time transparency as a foundation for successful optimization and planning and control of production? How can we actually, without taking a USB stick and going to each one of these line servers individually, how can we optimize the rollout of configuration across hundreds of manufacturing plants? How can we use machine learning in production control, for example, to improve quality or to do visual inspection? How can we actually feed the data that we gather at the machines somehow back to the central environment where our developers and our data science sit, so that we can leverage big data technology for analytics, for example? And how can we overall speed up the software development and release cycles for new applications in the manufacturing plant? Well, what we need to do that is multiple things. We need to somehow accelerate the software-driven production optimizations. We need to introduce, or our customers want to develop new features and that are targeting manufacturing applications as fast as they're doing that with their other business applications. We want to use container technology because we've learned to love that in the cloud environments, and we want to do that in a way that is controlled and auditable. We want real-time transparency, so we need real-time insights and actionable data, both at the edge as well as in the central data center. We need a way to process and analyze that data and make it and visualize it. And for that, we need to be able to use standard messaging protocols based on open industry standards. We want to do a declarative configuration management because basically Kubernetes has taught us that this is a great thing, that we don't worry about a procedural approach to deploying stuff, but we want just to declare a target state, even though it covers only the edge and the central data center. And we want the system to converge to that desired target state as fast as possible. That would allow us to do these agile and controlled configuration software rollouts, but it would also give us a chance to actually have a point where we can enforce, for example, auditing, because we only then need to audit who changed the desired state, and that would give us an insight as to who did actually a modification at the end. And we can center our approval processes around this. And we see that a declarative model also scales to 100 production lines, just because we know that also such a declarative model scales to thousands of cloud nodes today. And to leverage big data and machine learning technology, we need to collect and normalize and visualize the data. We need to make it accessible to data science and be able to basically develop and deploy machine learning models, not only, again, in the central data center, but again, to the production line. So how did we approach this in our thinking? We said, okay, we want to use basically a container-based continuous integration, continuous delivery from the data center to the edge to address the requirements of coding and simulation and deployment to production. We want to use declarative config management, and for that we are using a GitOps-based approach. And most of what we saw with GitOps was targeting a single cluster, and we were looking at, well, how can we extend that just from a conceptual point of view to cover multi-cluster environments. Data processing from sensors to analytics, we're using an open source middleware and AI ML stack. More specifically, we're using the Open Data Hub that was also mentioned yesterday in order to bring up all the machine learning tools that we need based on Kubernetes and OpenShift. And we want to do model training and deployment to production there. The Open Data Hub actually helps us because it can be integrated in our continuous integration, continuous delivery story. So what we've built in our demonstrator is really a small sample application. It consists of something that simulates data acquired from sensors, and a application that consists of basically a messaging broker, Kafka as event bus, a small web application that depicts sort of the current state of the sensor data that's being acquired and some form of analytics, which helps us to detect outliers and alerts the operator, the machine operator, in case something happens. And the way that we envision it is that we have 3 different environments that are of relevance. One of this is the line data server, where the actual sensor applications reside. And we have a second execution environment, which is the factory data center, where the rest of this application sits. The developers and the OT operations guys, they don't sit in either the factory data center or the line data server. They sit in the central data center, and they basically build and deploy the application that is depicted here. One thing to notice is that we assume that there's a strong firewall between the line data server and the factory data center, so the line data server is protected. And in order to allow the sensors to actually connect, or the sensor simulators to actually connect to the AMQ broker, right, there needs to be port opened here. And for that, we've built an operator that allows us to actually enable and disable firewall rules, basically, again, based on the declarative approaches. In order to do all the deployment, we said we're going to use a GitOps-based approach. We chose Argo CD as our deployment tool here that allows us to basically take the declarative state in a Git repository and apply it to the set of clusters that is out there. The next slide will show a bit more complex view of what we actually built, and the demo is rather extensive and probably running through each one of these model aspects in detail will take us well over the time that we've allotted for this briefing, and it can probably spend a whole day around this whole demo scenario. But basically what we can show based on this factory edge demo is, for example, how to, first of all, do a basic application deployment. How can we declaratively deploy an application that spans both the line data server as well as the factory data center, as well as aspects of the central data center? The second thing that we usually do is then how can we actually do a configuration management? How can we change how the application operates? We usually then change gears and says, okay, now that we've seen that we can deploy the application itself and configuration, what about actually changing the application? So we do go into code-ready workspaces, bring up a browser-based IDE, do a coding change, and then run our continuous integration, continuous delivery Tecton pipelines to create new container images, and then those are meshed against with the GitOps approach so that they're automatically staged to the test environment. They're tested there, and once sort of the test concludes, they're basically sent for approval so that the production environment can also be updated with the latest versions. For those customers who are really interested in the deep core technical stuff, we can go into discussing how to actually build an operator which manages infrastructure components. So for example, firewalls or even other stuff that might be required in such a scenario. And then we have a demo module around how can we manage multiple clusters. A story which we still going to improve, because with the capabilities that we've now in our portfolio with Advanced Cluster Manager, that becomes a much richer story. The 7th demo scenario is really how can we actually now bring the data that we collect in the factory to the central data center, for example, for machine learning training, but also, for example, if a developer support needs to understand what is actually happening in the factory, we need somehow insight into what is happening there. So how do we actually transport that data? And we're using Kafka and Mirror Maker there to forward the data from the factory data center to the central data center, where it is made accessible both in Kafka as well as in S3 storage. And based on the data that we have acquired in S3, for example, that's our last demo module, we can show how we can actually do a machine learning, can detect outliers in the data, and push that back again as an updated model into the factory, where we can then update the outlier detection. So that's basically the end-to-end demo, and I would dive right in and try to cover one or two of those demo scenarios in the next couple of minutes. So the way that we've done it, I would start with basically what has been pre-built. So I'm now looking here in our GitOps repository. And the interesting thing is you can see there multiple directories, but basically in our config instances, we have different sets of applications we can deploy. Sorry. And the one that is interesting to us is really this Manuela StormShift instance, which consists of these three parts that I mentioned before. We have the line dashboard, we have the machine sensors, and we have the messaging thing. And those are configured as 5 different components that we can sort of deploy. We have the individual components here, the messaging application, the machine sensor, the line dashboard, and we have our custom resources which define firewall rules which allow us to open ports here. And why did we make it that way? Why did we put everything into a single directory? We understand that basically we want to be able to understand and reason what an application looks like in its whole context. So basically all the components that make up this application, they're basically here in a single directory, and we can look at all the contents here, all the Kubernetes artifacts that make up this application, and understand basically how that application operates and how it works. But that is not how the application is actually deployed, because parts of those actually go to one cluster and parts of those go to another cluster. So let's take a quick look at what our actual infrastructure looks like. Need to step out of the presentation here. So in our demo scenario, we have 2 different OpenShift environments, right? We have one over here, and we have a second one over here. And I assume you cannot read this yet, but if I zoom in a little bit, you can see there's a number of stuff already deployed, but the actual application, anything with Manuela StormShift, is not there yet. And the way that we wanted to do the deployment declaratively is through GitOps. So we've deployed Argo CD, and Argo CD has a configuration which says basically anything in the factory data center, anything that is deployed into GitOps in the factory data center directory will then be instantiated automatically in the cluster. So that's what I want to do now. I want to basically take the configurations that are there and deploy them to the different clusters that are out there. To this end, I will switch over to my console. I'm in the Manuela GitOps directory here, so let's change into the deployment directory. Here you can see I have different execution environments, so I'll switch into, for example, the line data server execution environment, and here I will simply symlink the configuration that is out there, the Manuela StormShift. And here I want to have the sensor data, the sensor application. So I just symlink this one here. I'll do the same for the execution environment that makes up my factory data center. So I symlink the configuration that makes up the messaging layer, messaging application, and the line dashboard. And as a third thing, I have a separate directory where I can store all the stuff that makes up the network path between the line data server and the factory data center. And here I'll symlink the HTTP rules. So we can assume that each one of these 3 directories represents a different target cluster. We'd have a target cluster where the applications that are running on the line data server run on. We have a next cluster that represents the factory data center, and we have a third cluster that represents some form of management cluster that hosts the firewall configurations, for example. And here are the firewall rules. We have HTTP and we have HTTPS. So if I now look at git status, I see those 5 changes. So let's git add basically everything, git commit, do a initial deploy of Manuela app. And before I git push, just want to check the state again of that is currently out there. So I'm switching back to my project here. You can see there is no Manuela StormShift deployed components deployed here. Same over there. There is no Manuela StormShift deployed over here. And if we look at our firewall, probably we'll have to log in again. Let me check. Might be a bit slow. Here, the firewall rules that are configured neither on the WAN or on the LAN interface, you can see any significant rule that is out there. And now by simply git pushing the changes that we made, sorry, where's my command line? We will trigger basically an update of the operational Git repository. And usually the way that Argo CD works, it's basically polls the Git repository every, I don't know, 5 or 6 minutes. I can certainly speed that up just by basically telling Argo CD to sync, which is what I'll be doing now, just in order to speed up the demo a little bit. But you could certainly expect, and you can already see it already picked it up, so it sees now that there's new applications that are out there. So it already did sync as the Git repository. And what you will see now is that you can see new applications being deployed here. You can see the Manuela StormShift dashboard and probably in the next couple of seconds also the messaging layer. The rollout will take a couple of seconds, and you can actually monitor that. So for example, by opening the application, you can actually see what's happening. And Argo CD is quite intelligent in the way that it does it, because it allows us, for example, to do it in stages. So we first, for example, can do a stage where we update all the operators and register them with the system. And only once the operators are registered, the custom resource definitions are installed to the cluster. And then we can, in a second wave, automatically instantiate all the custom resources that are associated with it. So while the rollout is happening, Argo CD does it for us automatically. We don't have to do anything beyond actually updating the Git repository. Let's take a look at the application. I just need to check what's about the other one that's being rolled out. That's this one over here. Yeah, this is still in process of being synced. So we can certainly already take a look at the dashboard, where we can't expect it to work yet because the underlying messaging layer is still being rolled out. But that doesn't matter much. Take a look here. Developer view is probably the better overview. At this point, right, it's basically just a single deployment that has a route attached to it. And if we open it, we get a nice dashboard. But there is no real-time data yet, because the messaging layer is in this at this moment still being rolled out. That's a good one. Sync failed. Let's see what went wrong. Probably didn't do the preparation right. Oh, okay. I know this one. I thought I fixed it, but let me quickly fix it now. What happens is if you uninstall something, especially the Selden that we use, the Selden operator, it leaves a webhook behind. And because the application is now not there anymore, it tries to call out to this webhook. However, the webhook is, or the application is not there that this webhook points to. And this is why we get a fault. So let me quickly try to do that now and remove the webhook. Now this is not scripted, unfortunately. I need to log in as administrator. See, one webhook, two webhooks. And let's look for Selden. Here we see that there is this webhook still configured, which points to the application we just want to deploy. So let's just get rid of it. And voila, if we sync again, it should work now. So assuming that the messaging layer and the sensors are still there already. So the sensors are running on the second cluster over here. We see that we can now have 3 different data sources configured. We have our pump number 1 and the pump number 2. And pump number 1 and pump number 2, they send vibration and temperature data. But pump number 1 is only sending vibration data and no temperature data. So this is certainly something that we want to change as our second use case. So we've proven now that basically we can deploy an application that consists of multiple components over different clusters. We have cluster number 1 and cluster number 2 here. The sensors are deployed to one cluster. The rest of the application is deployed to the second cluster, all of them from the central data center. And now we want to do a configuration management change. So basically, in our manual storm shift machine sensor configuration, we have this config map, and we can see that temperature enabled is false. We simply set it to true, store it again, and I'm not doing it through the console now. Let's do it through the UI here. I add the change and say enable temperature sensor and push it again to the central repo. And once Argo CD is picking up the change, I would expect, let me quickly trigger that here. Once Argo CD configures that change, it basically updates the config map, restarts the machine sensor in the background. I would then expect in a couple of minutes the 4th data source to automatically appear in our factory dashboard. Let's see where we are. It's being synced, so what we can also check in the meantime is, did our firewall rules actually change? And yes, you can see here, we have 2 new firewall rules here in the middle, which had been generated by our operator, because sort of with the application rollout, we also declaratively said we want the firewall between the sensor and the application to be opened, and this is what happened here. Let's see. Our real-time data is now getting the 4th data source, or what's happening in on the sensor side. If that doesn't work, oh, it's still starting. This is why. So the new one is still not ready yet, and once it's there, now the 4th, basically the 4th data source is now also arriving. So usually with GitOps, it happens asynchronously in the background, so I'm a little bit eager and always expecting data to arrive much earlier than it actually does, but here's now the 4th data source also arriving. So we've now shown we can deploy an application, we can configure infrastructure like a firewall, and we can do config changes all from the central data center to the edge. I want to skip over the application development and the more complex use cases here. Basically, what we would show there is how we can, for example, to run Tecton pipelines. We have our continuous integration environment here and deployed our Tecton pipelines here. And we have a number of pipelines built that we can then, for example, use to do a build and staging. So basically we can use, for example, in our pipeline here, we clone our development and our operational environments. We update sort of a build version, then run the source to image build at the same time in parallel. We modify the operational repository to point to the results of the new build. Once that is complete, we sort of tag the development environment with the build number. We commit our operational repository, push the operational repository so that it points to the new tagged image. We then again trigger Argo CD to sync everything into our test environment, run a suite of tests, and then we trigger a staging to production. That's our pipeline that we would then walk through in detail. What I've also already deployed here is our Kafka and S3 integration. So basically what happens in our OpenShift environment is that we sort of pick up the data and forward it through Mirror Maker to the central data center. And there we store it then in S3. So this is also what's happening here. We have OpenShift container storage deployed that provides us with S3 buckets. And there we have our Manuela data lake that contains already a large number of objects that are stored here. Scroll too much. So we have our temperature data and the sensor data that was gathered through MQTT, copied to Kafka, sent over to the central data center. And we have here now in our central data center all the sensor data available in S3. And this is where we would usually, and this is how I want to end this short demo, would switch over to, for example, Jupyter Hub to pick up and analyze the data. So we have created a Jupyter notebook where we sort of pick up the data that is gathered from the sensors and try to understand where certain anomalies come from and how to detect them. And in order to do that, we first of all need to pick up and cleanse the sensor data. We have then the raw data over time. We sort of need to label the outliers. That's been done there. We then try to figure out which one is the actual best machine learning approach to it, and we there compare and contrast three different kinds of models there. So is a decision table better, or do we take support vector machines, or using a Gaussian naive Bayes filter here? And basically we compare and contrast these approaches with regards to their accuracy and resource consumptions. And we basically determine in this example that our decision tree is the actual best approach. And this is then a small application that we then sort of build in and prepare for Selden serving. And this Selden container is then built again through our standard pipeline and sent back together with the trained model through GitOps in order to be picked up then and again at the edge. And then you can see the outlier detection model in action. So that is sort of a one-day demo day in, let's say, 20 minutes. So where are we today? We achieved most of that stuff. All of the demo itself is public in our Git repo. In the future, we want to focus more on this end-to-end messaging thing. We also want to look more at actually the cluster lifecycle management, so to really to be able to deploy also the infrastructure at the edge. So at the moment, edge infrastructure falls from the sky for us, and we're really keen to also show how we can manage and roll out and manage the lifecycle of the infrastructure at the edge. We want to also be able to do distributed monitoring and logging. For example, if somebody complains that an application is not working, it's probably not feasible to take the developer and drive them out to the factory. So we want to show how a developer can sort of access and connect everything that he is required in order to analyze and debug an application. And we're looking more at enabling GPUs so that we can really show GPU accelerated machine learning. That is, of course, not everything with regards to factory edge. So we find that this is a really, really hot topic and very interested for a lot of these manufacturers. And a number of topics now also come into play that are basically keeping us busy at this point. The impact of 5G networks is really, really great, because with 5G wireless technology, you suddenly now have the ability to connect tons of stuff in a highly reflective electromagnetic environment, because the whole machinery, right, is a huge pain to do traditional wireless approaches, and 5G is very well suited to that. And why 5G gives you both very high bandwidth connections. So if you're looking, for example, at autonomous transport systems that might have some LiDAR or camera sensors running on top of them, but the whole heavy lifting is done somewhere in an edge computing environment, that could be an interesting use cases. But can also do the very low latency telemetry type of use cases there, where you have tons of sensors just connecting wirelessly without them having to be connected to specific field buses, etc. So those open new challenges, but also new great opportunities in the factory environments. Another interesting thing is OT infrastructure consolidation. What we see is, in the past, every type of OT use case usually broke its own bespoke hardware configuration with it. So you have tons of hardware sitting next to each other, each one for a specific use case. And to date, right, the approach is to actually virtualize and consolidate that on a single hardware environment hasn't really been done yet. And at the moment, right, it's really hard to keep this in part aging hardware up and running. So this is also a really, really interesting topic. And once we go beyond actual monitoring and supervisory stuff, more towards actually controlling processes, we're dipping our toes into safety, critical functional safety aspects and real-time processing. And this is also a really, really hot topic there for us. So that being said, thank you for your time and your interest in our demonstrator and edge computing for manufacturing industries. And hopefully we have still some time for questions.
We do. We've got a couple of questions. And thank you, by the way, Wolfram. Great presentation and demo. First question is the upgrade schedule slower for manufacturing to ensure more stability and less downtime?
Well, it's certainly not a deploy directly to production if CI greenlight stuff. What we usually have is some form of maintenance windows that you need to comply with. Which, by the way, is just a configuration item in Argo CD. So you can just tell Argo CD, don't do any deployments between, or only do deployments in these hours or stuff like that. So yes, it's definitely slower, just because basically you don't want to interrupt the ongoing production flows, and you usually have to comply with these maintenance windows. And traditionally, of course, right, anything that was in the factory was a bit more sacred than other deployments. So it's both a process and mindset shift that is required to do more frequent updates, but there are also these technical issues like maintenance windows that apply here.
Okay. Second question, are we doing anything with computer vision on a factory floor?
That is an interesting one, because the role that Red Hat plays usually in that space is pretty much the platform and infrastructure providers. So I'm pretty sure that we have customers, and can't really talk about a use case here, but we have customers that basically use this this platform with all the capabilities has, also the GPU enablement to really do accelerated computer vision type of scenarios. But again, this is not where Red Hat has offerings per se that sort of directly address this target. It's more an infrastructure storyline for us.
So sorry to interrupt, but there was a demo of exactly this that was done by an intern working on Open Data Hub this summer. So we know we can do it with Open Data Hub. We have all the components for it, but there is no particular offering that we are supporting.
Yeah, thank you, Nick.
Okay, yeah, and there was a follow-up from Diane on that just to see if there was someone we were partnering with, but I think you've addressed that question. There's a couple comments from David Martin. I don't see it specifically being a question, but he is working on a project to deploy AI and AI to the edge using Open Horizon. So he's got a link there. He also notes that he did not see the Jupyter output being deployed to a hub infrastructure on premises.
Yes, I only did some hand waving. Yeah, we'll do that kind of mentioning. That is certainly the true observation. And basically the way that we do it is we take the model-lib and the Python code, run our continuous integration build, bake basically everything into a container image, push it to Quay, use Quay's replication features to make it available in the factory. And from there, we just do a Selden serving deployment. Basically, we have the Selden operator installed at the edge, and we have more than just 45 minutes. I'd be happy to show that.
Yeah, so then David followed up with how do you deploy your AI models?
Yeah.
So it's basically
just like that.
Yes, like that. Okay. And then we had another question. Have you considered using SaaS partners, example Datadog, for log metrics, traces, observability part to plug in rather than overcrowding the deployment?
Yeah, so this whole logs and metrics thing and basically aggregating everything together is still a little bit an open topic for us, an important topic. At this point, we haven't really looked at partner solutions because we first want to understand better what our own Red Hat Advanced Cluster Manager has to offer here, because it certainly allows us a certain degree of insights across clusters. Once the requirements that our customers go beyond that, I'm pretty sure usually our customers already have this already decided for a observability partner here that we would then look to integrate.
Okay. And then Diana had a follow-up question, which I believe Brian addressed, basically saying, does this tie into SAP that factories often run?
So the demo scenario itself is pretty much standalone, just for the reason that we cannot bring up also an SAP application environment in our demo environment, otherwise it will explode. But in practice, it certainly needs to integrate. I mean, you have, for example, if you do predictive maintenance, you have the plant maintenance functions, usually in SAP, so any work order or anything needs to then actually be dispatched to SAP. Or you have in actual production control, you then have the parts lists and the production orders, etc. So of course, in a real scenario, we would certainly have to integrate with SAP. And the good news is that we have a suite of components in our Red Hat integration portfolio that allow us to do OData through the NetWeaver gateway or do classic R3 type of RFC connectivity or do IDOCs, BAPI calls, whatever. So there's a range of capabilities that we can actually bring to the table in our Red Hat integration stack to connect to SAP.
Awesome. And then we've got a few more from David. He's asking if we're baking, back to the AI side. So you're baking the model into the container, is the question?
Yes, and I assume there's an underlying thought about this is, won't the container images get too big if we do that? So for our demo scenario, no, they don't. once we're really getting into the multiple hundreds of megabytes to gigabytes of ranges, we can certainly discuss if actually baking the models into the container images is the right approach. But for the scenario that we had in mind, it certainly was.
Okay, two more. Do you collect OPC-UA? I'm assuming that's the right way of stating that, data from an existing system.
That's certainly something we also want to actually add. So OPC-UA is the so it doesn't stand for anything anymore. It used to stand for OLA for Process Control Unified Architecture, which is basically a web services-based approach to control process or to connect to this type of equipment. Let's put it this way. And the key difficulty is we haven't yet been able to find a Linux-based, because that's much easier for us to replicate than Windows-based, OPC-UA server. I think we need a server in this case that is on an open source license. So everything we found is either proprietary or Windows-based, which makes it a bit harder for us to integrate into our demo environment. But we'd love to do that because we think that MQTT is probably compared to OPC-UA rather than niche protocol, and most factory deployments will support some form of OPC-UA.
Okay. Next question is, do we use EdgeX Foundry?
Maybe Nick will also step in here. We don't use it in our demo. I think we're certainly monitoring what EdgeX Foundry is doing.
Nothing to add.
Yeah.
Okay. And then a comment again from David about using Open Horizon Edge Sync service as a means to deliver models dynamically. It can sync models in 10 gig in size.
Okay,
That's just a
that's good to know.
Awesome. Okay, so I don't see any further questions. Give it a couple of seconds to see if any more pop in. Good stuff. Thank you. Glad you joined, David. Awesome. All right. So with that, I think we're good. Thank you, Wolfram. Great presentation, great demo. Thank you, everybody, for joining us. And looking forward to further conversations on edge computing with Red Hat. Thank you.